Welcome to today's lesson on Pride's Data Literacy Training, where we will learn about the concept of data. For this course, we will first define what data is, differentiate the types that we commonly encounter, and finally, look at some examples. Let's begin. What is data? The term data is simply defined as facts and figures. It is raw, unorganized, and has no context or meaning. To understand this further, let's take a look at these numbers. These numbers can represent anything from salaries, or maybe scores, or even prices of your favorite products. They can mean literally anything. As you can see, these numbers do not have any context unless we organize them and give them meaning. Now, if we organize them and label them, then these numbers now have meaning. As you can see, these are actually population of barangays in City 1. That is what we call information. Information is the processed, organized, and structured version of data. It provides context and enables decision-making. In simpler terms, information is equal to data plus context. Now that we have that information, we can use this to make decisions like allocating the budget of City 1. For example, here, we can allocate it proportional to the size of each barangay's population. Since Barangay B has the largest population, it will be given the highest budget allocation. So, what we gained here is knowledge. Knowledge is a result of understanding information and using that to make informed decisions and solve problems. To make it simple, knowledge is now information plus application or use. Okay, now let's proceed to types of data. First, we have file types. Does this look familiar? This is our computer's file explorer, and you have probably seen the following files. First, we have comma-separated values or CSV, and then sometimes we also have Excel spreadsheet like this one. We also have PDF file, text file, Word document, image, voice recording, and video. The files on the left are in a format called machine-readable, meaning it is structured data that can be easily processed by a computer. Let's take a look at these two examples of machine-readable files. First, we have comma-separated values with a file extension of .csv, and then we have Excel spreadsheet with a file extension of .xlsx. Both of these files are by default opened in Microsoft Excel. As you can see, they contain the same data. They contain the budget allocation of City 1. The only difference is that, here in CSV, the data is broken down to its most raw format, hence, there is no formatting at all. Unlike in Excel, where you can do any formatting, like change the color of the cells, the font style, the font size, etc. And as mentioned, machine-readable files should be structured. Hence, it is contained in rows and columns. Going back to our file explorer, the remaining files are, as you guessed it, in non-machine-readable format. They also have data, but they require additional steps before we can analyze them. Scanned or photographed documents, which are usually in a PDF or image format, would have to be converted to machine-readable first before we can perform analysis. This is either done by human intervention, wherein we'll need to manually encode the contents of the file, or extra processes like specialized software to extract the data. This tree, on the other hand, can also be analyzed, but they would require advanced techniques like machine learning or artificial intelligence. For us to understand better, let's look at this example. Here, we can see the budget data as a table in Word document. This data then is not machine-readable and would have to be converted to machine-readable format first before we can do any analysis. On the other hand, if we have the same data in a CSV file, then this would already be machine-readable and hence ready for analysis. As an analyst, I would be very happy if I'll be given data like this one on the right, because analysts have to spend most of their time cleaning data. For them to produce quality and accurate analysis, they have to ensure that the data is already cleaned and ready for analysis. Having a machine-readable format, ideally CSV or XLSX file, will save them a lot of time, hence will make their analysis more efficient and a lot faster. Aside from the aforementioned files, we can also store data in databases. A database is an organized collection of structured data stored and accessed electronically from a computer system. It can be located on-premise, meaning the data is stored in a computer in your local office. This is what we usually use here in the Philippines. It can also be located on the cloud. One example is Google Drive. Your data or files is stored in the cloud or in the internet. Here are some of the famous companies that provide database services. We have Oracle Corporation, MySQL, which is open source, and SQL Server by Microsoft. We access data from these databases by using a programming language called SQL. Here is a sample code of retrieving data. We want to select the ID information, name, and age from the employee table in the database. Running that will result to something like this. It will show us the ID, name, and age of all the employees in the table. Now we've learned different file types and formats, but we have one more type of data that we need to learn, and that is metadata. Metadata is simply data about the data. It provides information about the data and not the content of the data itself. Confusing? Let's take, for example, a book. The data in it is the content of the book itself. Metadata, on the other hand, are the title, the author of the book, publisher, table of contents, number of pages, because these describe the book itself and not the data it contains. Let's take another example. As seen earlier, this is City One's budget allocation data. This is in a spreadsheet or table format. And the data that it contains is the content of the table itself, while the metadata is the title or description of the table name, the column names, and the sheet name, etc. Metadata ensures that we'll be able to organize and find the data, like looking for a file in your computer. It will be easy for you because you already know the metadata file name. Metadata also ensures that we can use the data. This is because you'll be able to know how the data is structured by looking at the metadata column names. That is why metadata is important. Finally, let's look at some examples. First, we have administrative data. These are data collected by the government or other organizations about their management and operations. Another is survey data. These are data collected from a sample of respondents that took a survey to replace or supplement existing data. Let's try to use both of these in a scenario. For example, what if we want to analyze business establishments in the LGU? To do this, we need data. We can use administrative data collected from business permit applications. Business owners will fill out an application form. Then, the LGU will consolidate the data in a file like this one. Business permit application is already a process in the LGU. Also, since they're from official documents, it is expected to be accurate. And lastly, it's most likely already in machine-readable format. On the other hand, we can use survey data to conduct the analysis. To do this, we'd have to go from one business establishment to another to collect data via survey. Hence, this will require more work and a lot of time. Also, it has a risk of inaccuracy if the survey is done by hand. Business owners and the personnel that will encode it may make a mistake. Lastly, similar to the file below, it's most likely in non-machine-readable format. Survey data is useful as it can be used as an alternative if there are no other sources available. But, if there are already administrative processes in place where we can get the data from, then we should leverage that opportunity and store it in a machine-readable format. But remember that both of these are complementary sources. We should use both administrative data and survey data for data-driven policymaking. Some other examples of administrative data are from civil registry, such as data from birth and death certificates. Again, first we'll have forms that are filled out, and then we'll consolidate them into ideally machine-readable files. Furthermore, if we combine data from birth certificates and death certificates, the resulting analysis can provide the LGU some sense of change in their population. Moving on, we also have other data like personal data sheet. This is submitted by government officials, employees, and applicants. This form is downloadable from the Civil Service Commission website. And as you can see, this is in an Excel spreadsheet or XLSX, hence is machine readable. Lastly, we have health declaration data that we are all familiar of. It is mandated by the government, especially during the COVID-19 pandemic. It is used to monitor our situation, for contact tracing, and other health-related analysis. It is usually done by hand and then photographed or scanned. Hence, is non-machine readable. Okay, to summarize, today we've learned what data is and the concepts behind it. Data versus information versus knowledge. Next, we identified the different types of data. File types, machine readable, database, and metadata. Finally, we enumerated some examples. Administrative data versus survey data, etc. I hope you learned a lot from this lesson. We hope to see you in the next one. Thank you!